Okay, class, so we're going to take a look at how to graph a system of linear inequalities here, which means we want to find the set of all points that are solutions to, both of those inequalities. We're going to do this by graphing because you're going to see that there are actually going to be a lot of points to solve the system, unlike a system of linear equations, which in most cases has just one solution. So we're going to do this by graphing both inequalities. Remember, when you graph an inequality, you've got to graph the boundary line, and then you've got to look at the inequality symbol and decide whether or not you should make the boundary line solid or dashed, based on whether or not we want to include, if there's an equal sign, we want to include the line. If there's not an equal sign, we don't want to include the line. And then we also have to shade one way or the other. We do that by testing some points. So just to get going here real quickly, you guys already know how to graph lines. Let's go ahead and graph the first one. Y equals negative 3x minus 1. So I'm going to start off here at negative 1, and I'm going to rise negative 3. So 1, 2, 3, and I'm going to run positive 1. It's going to take me to right about there. And then just to get a better look at my line, I'm going to also rise 3. So 1, 2, 3, and I'm going to run negative 1. It's going to take me to here. Now, because I have a greater than or equal to inequality, which means I want to include the points on my line, I want to draw a nice solid line through these points. So I'm going to go ahead and use my line tool and draw a solid line that goes through those 3 points. See how well I can do this. Well, that's not terrible. I've drawn worse. Alright, so there's my solid line. Now it looks like this line just misses the origin to the low side, but just to be safe, I don't want to plug in 0, 0 because in case my line is drawn a little bit offline here, it's hard for me to tell exactly what side of the inequality or what side of the boundary line 0, 0 is on. So instead, I'm going to go ahead and test a different point. I'm going to test the point 1, 0. So I'm going to test the point 1, 0 in this inequality. So here I go. We're looking at 0 in for y. 0 is greater than or equal to negative 3 times 1 minus 1. So 0 is greater than or equal to negative 3 minus 1, which just gives me 0 is greater than or equal to negative 4, which is true. So the point that I just tested, that point is a solution to the inequality, which means I need to make sure that I shade going this way. So instead of coloring it in, don't color this in darkly right now, just lightly shade to that side of the inequality. You'll see why in just a second. Now I'm going to switch colors. I'm going to graph the second inequality real quickly here. I'm just going to go ahead and go up 2. And then I'm going to rise 1, run 1. Takes me to right about there. I could also, if I wanted to, I could rise 1, run 1 again. I could also fall 1 and run negative 1. If I wanted to, I could do it again. Alright, so there's a quick look at the second inequality, the boundary line. I have to decide now if I want to do solid or dashed. This time I'm going to draw a dashed line because my inequality is a strict inequality, strictly less than. So I'm going to draw a dashed boundary line through those points. So there we have it. I'm going to test quickly the origin this time. I can test the origin because the origin is clearly on one side of this boundary line. So if I test the origin, I'm going to have 0 is less than 0 plus 2, which is 0 is less than 2. Well, that again is true, so I want to shade toward my test point, not away from it here. And I'm going to simply draw some light boundary lines like we did last time. If I wanted to, I could continue this. Alright, now, at this point, it's time to decide where on the coordinate plane do our solutions lie. Let's take this kind of region by region. We'll start in the easiest region. In this region over here, none of these points are solutions to either the green or the purple inequality. These guys are out. These are not solutions to the inequality. Let's go up here. These points in this region, these solved the green inequality but not the purple inequality. Remember, a solution has to solve them both, so they don't count. So if I wanted to right now, I could actually go through and erase any shading. But because I shaded lightly, you don't really have to go through and erase it. We can kind of go in and darken what we want to keep later on. So these points, no good. Let's move into this region. With the two boundary lines, these points, if you notice, they got shaded by purple and they got shaded by green. These points are solutions to both inequalities. These are all keepers. Every one of these ordered pairs, if you plugged it into both inequalities up top, it would, we would have solutions in all cases. Lastly, let's check down in this region. The points in this region all solve the green inequality, but they don't solve the green, or don't solve the. They all solve the purple, but they don't solve the green. I misspoke there a moment ago, but it doesn't make a difference. They only solve one of the two. They have to solve both to be solutions. So these guys are all out. If I wanted to, I could go back and I could do some erasing. Again, it's not totally necessary to erase. In fact, for you guys, you probably don't want to bother. What we might just do is maybe come back and just kind of darken in the region that worked. So all those points work. Just one more thing to note. When you look at the points on the boundary lines, since this boundary line is dashed, the points on it are not solutions to the purple inequality. If they're not solutions to the purple inequality, they can't be solutions to both. So we would not consider these points in our solution set. Points that are on the green boundary line, in this case, since it's solid, they are shaded by the green, and they're shaded by the purple because they're on the shaded side. So these points from the intersection on down, these points would be solutions to the inequality. So there's our first example of solving a system of inequalities. Basically what it comes down to is graph both inequalities, solid dash shade, and then look for where the shading overlaps. Hopefully this helps. Jump to the next video and take a look at how we can graph a system of 3 inequalities in 2 variables in a coordinate plane. And hopefully you'll be on your way to understanding this concept.